Hello. This is the first video of 3 in a series to cover the explanatory statistics that we're talking about this week and that are on your homework, homework 8, 9, and 10. The 3 explanatory statistics we're talking about are cross-tabulations, where the outcome variable y and the independent variable x are categorical. The analysis of variances, where the which is chapter 10. Crosstabs is chapters 11 through 14. Chapter 10, analysis of variances, where the outcome variable, the y, is continuous and the predictor variable or independent variable is categorical, the x. And then the third video will be on correlation, where both y and x are continuous. So what I'd like to do is kind of do some review of Chapter 12, which is the basic measures of association concept chapter, and then back into 11, where we'll look at some specific elements of the cross-tabulation process itself. And then we'll just reach briefly into Chapters 13 for a measure of association lambda, where both the y and the x are nominal, and a little piece of Chapter 14 where we have the gamma, where the y and the x are ordinal. Now it could be in this case the lambda, where either y or x are ordinal, or both are nominal. In other words, one nominal, one ordinal, or both nominal. And you'll see the logic of that here in a few minutes. So, and then I want to conclude this video with looking at the 2 demonstrations that I sent you in the email earlier today, one gun control by sex and one self-assessed happiness by class. I think by walking through those demonstrations that will help you to prepare for doing the homework that I'll be sending you tomorrow. That'll be due sometime next week. All right, so we are still in hypothesis testing, like we've been in chapters 8 and 9, 1 sample, 2 sample case, where we have a critical value and an observed value, or an obtained value. And if our obtained value is larger than the critical, remember that 5-step process, we're still in that. If the critical obtained value is larger than the critical value, then we reject the null. And this is true for the chi-square of the crosstab. It's true for the F statistics of analysis of variance, and it's true for the Pearson R in correlation. We'll walk our way through those in the subsequent videos. So it is hypothesis testing. Like you can see here in a crosstab, the null is y and x are independent of one another. In other words, y does not respond to any movement of x. They are independent. The research hypothesis is that y responds to x, so that there is a conditional distribution of y, more or less based on the movement of x. In other words, they covary. Classic illustration is why does income vary across a population, and then we hypothesize that its education is the covariance, so as that education goes up, income goes up. So here in the research, our hypothesis that our outcome variable is responding to something, and we place an x on the other side of the equation as what we think is influencing that. So that's the null in the research. It's very similar to what we were talking about in chapters 8 and 9. And again, we have an obtained chi-square, which you'll see, and then we'll measure that against a critical chi-square that we'll get from Appendix C based on a couple of things that we'll look at here in a minute when we get to the homework. And if the chi-square obtained is larger than the chi-square critical, then we reject the null. The same process of hypothesis testing that we've been doing in chapters 8 and 9. Now, I call this explanatory statistics, whereas the previous few chapters were more inferential, and then before that was descriptive. I call them explanatory because what we're looking at as we move through crosstab analysis of variance and correlation, we're not only able to see the relationship between y and x, that there is a measure of association, that there is an association, and we can look at what is the strength of that association, and we can see what is the direction of that association. So here, then, we call it explanatory statistics because we can explain, to some extent, we can explain how much of the movement of y, or the variation in y, can be explained by the movement or variation in X. How much does the movement of X explain the variation in Y? We might find 2%, we might find 40%, we might find 30%, might find 88%. That's the product of the analysis that we'll be looking at here in a few minutes. So I call it explanatory because we can, with these procedures, explain, to some extent, we can explain the variation in Y by the X's we put on the right-hand side of the equal sign in our equation. All right, so a couple things about the tables. This is cross-tabulation, two variables placed across a table, stretched across the table in order to analyze the relationship, examine the relationship. Here, the way we'll set it up, you can see it in Chapter 12. The columns are your X variables, your independent variables, and Y is your row variables. Now, what I've done is we've got one of our illustrations is gun control by sex, so I pulled the percentage distributions off that homework. And here's the male and female. We're looking at does gun control, attitude towards gun control vary by sex. So, excuse me, here we got males and females, favor and opposed. Now, we've got the frequencies. You'll see in the table on the homework, there's the frequencies, actual count. How many males said favor, how many females said favor, how many females said opposed, how many males said opposed. And but the frequencies are not always easy to the eye to interpret of which way the direction is going. What is the pattern of association here? But when we put it in percentages, we can see it. 85%, almost 86% of the women favor gun control, whereas almost 72% of the males favor gun control. 14% of the women are opposed to gun control, and 28% of the males are opposed to gun control. So here what we see is that both groups in this particular study favor gun control, women more likely than men. They both are over 50% favoring gun control, men less so than women. So here, nominal variables don't have a scale behind them. So when we're talking about the strength or the direction of the association, we can't say anything about a direction in a nominal variable without a scale. Intervals have an implied scale, so we can say something directional. So here we can talk about the pattern. Women, both males and females, favor gun control, women more so than men. That would be basically what you would say. And no direction, but we can see there's a strength and that there is an association. If there was no association, these percentages would be basically 50-50 or very close. The differences, like we talked about in Chapter 8 or Chapter 9, might only be trivial, but they would not be statistically significant. And the way we know they're statistically significant, the differences that we see here, is if the chi-square obtained for this table is larger than the chi-square critical for this table. In that case, we'd reject the null that the percentages we see here are only trivial in favor of the research, that they are actually statistically significantly different. Okay? So that's a basic idea of Chapter 12 in terms of introducing measures of association in the background explanatory statistics. Let's look at the homework demonstration, for the first one in cross tabulations. It's this one. I don't know whether you can see it. I'm sure you'll have it in front of you. Demonstration gun control by sex. Generally, when you see something like gun control by sex, even though it doesn't say Y equals X, you know Y, the variation of Y by sex, a variation in gun control by variation in sex. So generally, on the left-hand side of the by is your dependent variable, your Y, and on the right-hand side of the by is your independent variable, or your X. So when you come down to dependent and independent variable, then you just say gun control is dependent, sex is independent. Your null hypothesis would be, yes, that these two are independent, that there's no explanation that we can get in the variation in Y from knowing something about the variation in sex or gender. The research hypothesis, we would say that yes, Y is responding to X. The variation in crime control is responding to variation in gender or sex. You'll notice here at the consensus version of statistics, we're using the alpha of 0.5. You can use an 01, you can use something like a 10, but for the most part, 95 times out of 100, shall we say, we use an alpha of 05. Now we have degrees of freedom. Degrees of freedom is that demonstration I gave you once before, that if we had a sum of 10 and we had 4 up here and 2 places, then what in addition to 4 would make 10? We could do 4, 6, and the next one would be a 0, 4, 2, and the next one would be a 4 to make 6 to 10. This is a mathematical background that is necessary to do derive the calculations that we want, but we don't need to get into the philosophy or the mathematics of degrees of freedom. At this point, we just do it, right? So you can see the degrees of freedom are R minus 1, C minus 1, or the row minus 1 times column minus 1. We've got 2 rows and 2 columns, so 2 minus 1 times 2 minus 1 would be 1, would equal 1 times 1 would be 1, so our degree of freedom would be 1. So then we got the chi-square critical value, which we would find in Appendix C. So we go to our text, and we go to Appendix C, and you'll see in Appendix C that the left-hand column is degrees of freedom, and then you go across the rows, you'll see 99, 98, 95, 90, 80, so on, until you get to 05. That's generally the column we'll use. 1 degree of freedom, we go across till we get to 05, and we find that the chi-square critical for this particular table is 3.841. So we would enter 3.841 here. And then, in order to make the decision about whether to reject or accept the null, we go over to the table, and here down below in the chi-square test, we see a chi-square, Pearson chi-square of 58. Now then we say, is 58.6 larger than our chi-square critical? I'd say it is by far. So we would say that here, give the values of the critical and the obtained, and say that the obtained is larger than the critical, therefore we reject the null. Consequently, we can say that gender appears to be an influence on the variation in the attitudes on gun control. That would be the statement we'd make in our decision. And then you see we have a lambda here. The lambda is a measure of association in terms of how much can we explain by gender that variation in Y, our gun control. And when we look at the lambda, you'll see that it is 0.065. You can multiply that times 100 and you get about 7%. So then we would write here about 7% of the variation in gun control is explained by the variation in gender. Not very much, but it is statistically significant because our chi-square obtained is larger than the chi-square critical. So we might, as researchers, say, well, we got to explore that other 94%. But at least we have a valid finding here that is statistically significant. And if we're interested in gender influences on gun control, we got an answer. All right, so what I've been talking about here are the elements in Chapter 12, which is about independence and about the tables and using the percentages in your columns to be able to see the percentages across, and the independence. Now, in Chapter 12, you'll see that there are 2 kinds of tables you'll get, the one that's obtained and the one that is expected. The expected table, you won't do that for your homework, but take a look and see how the expected table is derived. The expected table is derived by the frequency table, not the percentage table, and the expected table is derived by, for example, and you can see the illustration, multiplying the frequency here to get the expected value in this cell, the frequency here times the frequency there, divided by the total here, and you'll get that value. The frequency here in the expected would be this value times that value divided by this. For this one, it would be this value times that value divided by this. And that's how you would get the expected. That would be the expected table if the null hypothesis were true. And then you'll see how you go through an exercise very similar that we did in the early days of chapters 8 and 9, and even back when we were doing central tendencies, where we subtract the expected from the observed, square the difference, sum it up, and get our chi-square statistics. You can see all that laid out in the table, but you won't have to do it for your homework. Okay, let's look at the self-assessed happiness by class. Basically, it's the same idea. This is the dependent variable y. That's the x variable. So you know what to put here. You know what the null hypothesis is now. You know what the research hypothesis. You know the alpha. We got degrees of freedom, but look, we got a different level of degree of freedom here because we have three rows and 4 columns. So 3 minus 1 times 4 minus 1 would be 2 times 3 would be 6. So then we go to the appendix C, go down the left-hand column until we get the degrees of freedom of 6, go right across that row until we come under alpha of 05 and take that critical value. Whatever that critical value is, you take that and you enter it here, the chi-square critical, and then you look at the chi-square observed, 183, very large. Likely you're going to, when you do this demonstration to yourself here in a little while, you would reject the null because your chi-square obtained is very much larger than the chi-square critical that you'll get from appendix C. So then we look at the gamma. Now the gamma, you'll notice when you look at these variables, they're interval variables. Lower, working, middle, upper. We don't have values here, but we have a sense of things getting more as we go from left to right. And here you've got very happy, pretty happy, and not too happy. And you get a scale there, you know, very happy, not so happy, and happy in between. There's an implied scale. These are interval variables. So we'd use the gamma. Go to chapter 14, and you'll get there's 3 or 4 pages that tell you about the gamma. Just like when you go to chapter 13 for lambda, there'll be 2 or 3 pages that tell you about the lambda. The gamma, one of the things about the gamma is it's the same thing. You get the gamma, and you multiply it times 100 to get what percentage of self-assessed happiness is explained by class in this case. And you'll see that you get a value of 0.311. Now, this captures direction. So that if this were an inverse relationship, in other words, if as class went up, self-assessed happiness went down, we would have a minus 0.311 here. And perhaps it'll show that. I think it will. On one of your homeworks, you're going to get a minus gamma. That will tell you then that you've got an inverse relationship there, that you have to think about what that means and describe it in your decision about the lambda. So here we got 0.311. So that's a positive thing. So then we would interpret this that as class goes up, happiness goes up in terms of self-assess. And sure enough, lower class 14%, working class 25%, middle class 37%, upper class 44%. We can see the gain, if you will, of happiness. So then when we multiply this, we would say that the sense of self-assessed happiness, that variation, the objective class identification explains 31% of that variation. Okay. That is, in a nutshell, probably a little big nutshell, right? Hypothesis testing explanatory statistics, number 1, Crosstabs, chapters 11 through 14. Next I'm going to do the next video will be on the analysis of variance. It'll be shorter than this one because we don't have all that chapter 12 background. So see you in a little while.